Today we'll understand everything about audio formats from scratch. So what is an audio file format? Imagine recording your voice. Your computer cannot understand sound directly. It converts sound waves into digital data. The data needs to be stored somewhere. That storage method is called an audio file format. For example, phone recording, Spotify music, WhatsApp voice note. These all are audio files but are stored differently. So now the thing is, what is this audio coding format, the container, and the audio codec? Let's take this analogy. Imagine sending a gift. The box is the container. The gift inside the box is the audio data. The delivery person who delivers this whole gift is the codec. So here we have the container, audio data, and the codec. First, let's talk about the audio coding format. The audio coding format is the actual bit layout of the audio data, excluding any metadata. It is the structural architecture of the ones and zeros that represent the sound. Examples for these are LPCM, FLAC, data, MPG1, MPG3, and more. Next, we have the codec. So codec stands for coder decoder. This is the active software layer, the algorithm engine. A codec performs the actual mathematical encoding and decoding of the raw audio data. Into that specific, when you are recording your voice, the codec is the software that analyzes the raw analog to digital signal, applies psychoacoustic algorithms to strip away unneeded frequencies and compress it. And later, when you press play, the codec is what unpacks the compressed bit stream back into something your hardware speakers can actually play. For example, we have FLAC, then ALAC, then we have PEG and more codecs. Finally, we have the container. This is what you actually see on your hard drive. A container format is a storage layer that wraps around the raw encoded bit stream. Why do we need it? Because a raw bit stream has no context. The container provides the metadata header. It tells your media player, hey, this box contains PCM audio running at a 44.1 kHz sample rate with 2 channels. Example for these are WAV, AF, MP4, OGG, and SAS format. Although most audio file formats supports only one type of audio coding data, but we do have a multiple media container format as well to support multiple types of audio. For example, Metroska, which is the .mkv, or AVI. So just now we discussed what is the container, what is codec, and what is the audio coding format. Now that we know how files are packed, let's look at the actual data inside. Every audio formats you will ever use falls into one of these three distinct categories: uncompressed audio, lossless compression, and lossy compression. So let's start with uncompressed audio. Think of uncompressed audio like saving a massive raw photograph where every single pixel is perfectly preserved. It is the exact unaltered digital representation of a sound wave. Example formats for this is WAV, AIFF, and raw PCM. The advantage of this is that you get the absolute highest quality possible with zero data loss. The disadvantage is that the file size will be much larger for this one. Next, we have lossless compression. So what if you want that exact same uncompressed quality, but your hard drive is running out of space? You use lossless compression. Think of it exactly like a zip file for your audio. The computer simply stores the digital information much more efficiently. It mathematically compresses the data, and when you hit play, it perfectly reconstructs it. The example for this are FLAC, ALAC, which is Apple's lossless compression, Webpack, and Monkey's audio. These are the formats. Finally, we have lossy compression. To make file sizes small enough to stream instantly, we use lossy formats where it permanently removes audio information from the file without making the sound broken. It relies on psychoacoustics. The algorithms strip away the hidden frequencies and background data that the human ear naturally filters out anyway. You usually don't even notice the missing parts. For example, MP3 is the most common one. Then we have AAC, Opus, and 4vis. These are the audio formats. Now, lastly, I want to credit Wikipedia for this information. I will share the links in the description. If this video helped you understand audio formats, let me know in the comments and don't forget to subscribe.